All right, this last section is about it's a couple extended ideas. Below is the function f of x is a trinomial function now, x squared minus 3x minus 1, and the inverse is g of x. We could even go ahead and just write this as f inverse because we're used to that notation, right? Write an equation for the inverse using algebraic methods. Then verify your equation with points from the graph. Well, if you look at this, we already know that inverse of f has a problem, right? Because technically this side shouldn't exist. Well, not just that side, but this part shouldn't exist because that's all negative numbers and you can't spit out negative numbers in that part, that radical looking idea, right? So we're going to have to see what function we can get out of this. Let's start with y equals x squared minus 3x minus 1. Okay, starting off normal. Let's just go ahead and invert it. So x equals y squared minus 3y minus 1. Here's the problem. The only way I know how to undo this y right now is factoring. But I can't factor because it's not equal to 0. So I could factor. Actually, I can't even factor this. This isn't even factor, right? -1, the only options are 1 and -1, and that does not add to 3. So we're going to have to go to quadratic formula. Quadratic formula for things you can't factor. But this doesn't equal 0. It could at one point, but we can't guarantee it equals 0. And so we're actually going to have to subtract it to the other side. And so what we end up with is 0 is equal to y squared minus 3y minus 1 minus x. Now, once we find an x, that will be a number, right? That will just be one big number. So if we were to go to our quadratic formula, in this case, we're solving for y. Y is equal to negative b plus or minus the square root b squared, b squared minus 4ac all over 2a. Well, b is pretty nice to find. Negative of -3 plus or minus. Again, b is pretty nice to find. Minus 4, a is 1, but here's where it gets a little interesting. C is not a single thing this time. C is going to change based off what x is. If x was 2, then c would be -3. If x was 5, then c is going to be -6. And so until we know x, we can't plug in anything but the function. But that doesn't mean we can't. We've plugged functions into other functions before, right? We've done that so many times. And so we can just plug in that as kind of a to be decided later moment. And then we know 2 and a is 1. So let's go over here and see if we can simplify this now. Go all the way up here. Let's see, we got 3 because those negative cancel. I'm only going to simplify what I can. Okay, I'm not going to force anything super fancy to happen. -3 is 9 when you square it. 2 is on the bottom. Here's where it gets a little strange. Let's see. That would be -4. So let's start there. -4 times this c that we have. There I could distribute, copy, paste everything else real fast. 9, 2. Distributing a -4 would give me a +4 and a +4x. And then it looks like I can combine some like terms. 13 plus 4x and 2. All right. So we've got that now. Here we go. This is our function. Not a function we're used to seeing. It's very, very strange, but this would be f inverse. Whoa. Weird looking function. Okay, let's go back to the picture now. Let's pick, let's see, g of x, we've got 3, 4. Let's pick that one. 3, 4. Now, so if we plug in 3, we should get 4. So let's go ahead and go down here, plug in 3 to our x value over 2. Let's see, 3 plus or minus 13 plus 12 over 2. Well, 13 plus 12 is 25. Therefore, we get 5. Here's where we split off, get two answers. 3 plus 5 over 2, which is 8 over 2, which is 4. Lovely. 3 minus 5 over 2, which is -2 over 2, which is -1. Huh. We ended up with 2 answers. That's fascinating. I plugged in 3. I did get 4. Why would I also get -1? Let's go back to that picture for a second. Oh, hey, look at that. -3, -1 is also on this function. So that's like getting two answers, but both of them were in fact on this g of x function. And that proves that this is the function. So this plus or minus symbol here is giving us both sides, which is very unique to when you have a quadratic trinomial. And that's kind of cool. So inverse is valid. Check. We are good. All right, the last one here. Again, this is kind of an extension idea. You don't normally talk a lot about inverses of trinomial quadratics. The more quadratics of inverses you talk about are these ones, where you don't have to worry about that. But it's just kind of a fun idea. Let's do one more activity with inverses. We're going to see if we can figure out whose inverse is who inverse, and then make some ideas about what kind of inverses you get from what. Well, if we had to take a guess here, if I had to guess which would be inverses, take a second for yourself and make a guess. If I had to guess, I'd say probably the rationals. Maybe, right? A rational ends up getting you a rational. A linear ends up getting you a linear, right? Maybe, I don't know. It could be the case. If I have a cube, maybe the cubes will give me the same thing, and maybe the roots will give me the same thing. Right? So maybe these two will match. Maybe it matches like that. So that's my guess. Let's go ahead and just go down ABC. We'll see if it matches up with DEF. If they don't, we'll go through DEF and find those two. So let's look at A here. How do I find the inverse? We do y equals 8x cubed, x equals 8y cubed, divide by 8, and cube root it. So far I'm not seeing any function over there, but I do know the cubed root of 8 is 2, so maybe I could even clean this up a little bit. And it looks like I end up with k of x. So I was wrong. I was wrong on this one. It's not a cube giving me a cube. It looks like the inversion, of a cube would actually be a cubed root. But that also makes a lot of sense. So a cube would give me a cubed root when inverted. Fascinating. All right, let's go down here. I have a square root now. Maybe I want to adjust my idea. Well, if a square is going to give me or if a cube is going to give me a cubed root, a square root should give me like a square, right? And I don't have any squares on this. So I'm thinking there may not be an inverse to this one here, but let's take a look. So we've got y equals the cubed root of x plus 3, invert, square both sides, and then subtract 3. It looks like they were trying to trick me with m of x there. M of x is not the inverse, pardon me, I'm having trouble talking today. The invert of g of x. In fact, it's not even related. It doesn't look like that's going to be an inverse anywhere. So let's just go ahead and box that itself. Let's look at that rational now. Maybe rationals together. We have seen that before. I wouldn't see any reason why I would get some kind of weird upside down, but let's double check. So I've got y equals 3x over x plus 3. Ooh, unfortunately, this has a couple y's in it, which is going to make it, a little more challenging to solve. Notice, key point here. When I inverted the function, every x changed to a y, not just one of them. All of the x's changed to y's, each of their own individual y. I get a lot of people who will just try to do one. All right, so solving for y, I think my first issue is still a denominator. I still want to get that out first. In past examples, we've now moved the x back, but that was because there wasn't any y's on the other side. So I think I actually am going to start breaking this up because I want to get all my y's on one side. And I can only do that if it's not stuck inside a parenthesis. Now I think I'm going to move this x over. Actually, you know what I'm going to do? I'm just going to move this y over to its buddy y over here. So 3x is equal to 3y minus xy, because that's the same thing, right? Then I will factor out a y and move the thing that is not y back. So now that it's all by itself, I can move that thing back. And it looks like it is the inverse f of x. So h of x and f of x are indeed inverses. Do we have two f of x's on here? Oh, j of x. I'm sorry, j of x. I just didn't see that. So this is j of x. Fascinating. And you know what? We were right on this one. That's good. Gold star for us. That actually makes sense because when you invert a regular fraction, 1/2 to 2 over 1, you get another fraction. So fractions will flip around to being fractions again. Okay, so rationals will give us rationals, cubes will give us cube roots, square roots will give us squares. The only one that we didn't get an actual inverse for was m of x. So let's see what happens when you have this cube. Make a prediction. I think this is going to be a cube group. X equals y cubed minus 2, x plus 2 is equal to y cubed. Cube root it. I was right. Now that inverse relationship, so since it doesn't have one, we'll just call it m inverse of x, right? That inverse relationship you can kind of depend on and leads to some very cool graph conversations. Right now, it's just a happy noticing that if you have a cube or a power, you're going to get a root of that index, right? So a cube to cube root, square to square root, fourth to fourth root. If you have a rational, you're going to pop back out a rational. If you have a linear, you're going to get a linear. Absolute values invert to absolute values, which is kind of fun. And there's plenty of other ones. Right now, we're just going to go on to 9.2, and I will see you there.